Hello everyone, today we'll be solving the problem number 973 k closest points to origin, right? So what the question states here, we are given a list of 2D points. See here, we are given a list of 2D points, right? So what we need to do, we have to return the k points that are closest to the origin 0, 0. So just give me a second here, 1 second. Yeah, 1 second. Yeah, we have to return, this is 0, 0, right? This is 0, 0 basically. We have to return the k points that are closest to the origin 0, 0. The distance is computed using the Euclidean formula or the Euclidean distance, right? So Euclidean distance states square root of x square plus y square. Simple man. Square root of x square plus y square. But we can skip the square root for the comparison. But we can skip the square root for the comparison. We may return the answer in any order. We may return the answer in any order. Order doesn't matter basically, right? Each point is a pair x comma y. Each point is a pair x comma y. So each point is a pair x comma y. Just remember this one, right? And we are guaranteed that a valid unique set of closest point exists. At any cost, one solution exists that they have given, right? So we have to use heap based approach to efficiently track the closest point. So we have to make use of the heap based approach to efficiently track the closest point. So this is what they have given in the question, right? Basically we have to go with the Euclidean distance, one thing, and what we need to find, we have to return the k points that are closest to the origin 0, 0, right? So one answer exists at any cost that they have given in the question, right? I hope the question part is completely clear. See here, um, we have the points 1, 3. 1, 3 means here 1, 3. This one here, the point they have shown here. If you can't see this one, just give me a second here. This one, 1 comma 3 and minus 2 comma 2, minus 2 comma 2. So here this is here, right? Minus 2 comma 2, this one is here. So k we have been given first, the k we have been given 1, the first closest point we have to go. So here the first closest point to the 0 comma 0 is this one, right? Rather than this one, 2 comma 3. So this one is the closest, right? So the distance between 1 comma 3 origin is square root of 10, and the distance between minus 2 comma 2 and the origin is square root of 8, square root of 8 basically, right? So they have strictly mentioned here, since square root of 8 is less than square root of 10, this one minus 2 comma 2 is closer to the origin. So this will be calculating, this we will be calculating based on the Euclidean distance. The formula is square root of x square plus y square, right? So we only want the closest k equals 1 points from the origin. So the answer is this one, this one, minus 2 comma 2. Same goes with a second example as well, right? So we have 3 comma 3. So you can just do it in the same way, man. We have 3 comma 3, this one here, and we comma, so here 5 comma minus 1. So this one 5 comma minus 1. So this one we have to consider here, right? 5 comma minus 1 here, this one we need to consider, and minus 2 comma 4, minus 2, where is minus 2? Minus 2 comma 4, this one. So output that we will be getting here would be this one, 3 comma 3 and minus 2 comma 4, right? So minus 2 comma 4 and 3 comma 3, order doesn't matter, they have given, right? Both are same here, right? Order doesn't matter, they have given strictly. So this is also accepted, they have given, right? So you can just uh, calculate in the same way that they've shown for the example one, right? Let's do one thing, let's go with the approach followed by the complexities, and then let's write the code. And the approach will be considering the first example itself. Let's go with the first example in detail, or let's go with the approach in detail, right? So here the first example we have here is, let me come here, just give me a second here. We have 1 comma 3 and minus 2 comma 2, right? We have to compute the distance from origin for each point, right? So here we have 1 comma 3 and 2 comma 2, right? Minus 2 comma 2. So this will be, we don't have to go with the square root they have given in the question, right? So we'll just go with the 1 square plus 3 square. Here this will lead to 10, right? 1 square plus 3 square is 1 plus 9, nothing but the 10. Here This one will be minus 2. Again, we have minus 2 comma 2, right? So this will be minus 2 square, minus 2 whole square plus 2 square, right? So this will be 4 plus 4, nothing but 8. 4 plus 4, nothing but 8, right? So here we will be making use of the, again, I want to just tell you this one. We'll be making use of the max heap or the max priority queue. We will be going with the max priority queue to solve this problem. Right? So just remember this. We'll be going with the max priority queue, right? So of k equals 1, of k equals 1. So here first what we will do, we will insert minus 2 comma 2. We will insert minus 2 comma 2. So this is fine. We'll insert minus 2 comma 2, and we will insert 1 comma 3. We will insert 1 comma 3. We will insert 1 comma 3, right? So we'll insert minus 2 comma 2. Heap becomes minus 2 comma 2. So first we will insert this one. Heap is minus 2 comma 2 itself, right? So when we insert this one, heap will be minus 2 comma 2 itself. Next we will insert 1 comma 3. Heap has two elements. Heap has two elements. So next, second one, we will insert 1 comma 3. We will insert 1 comma 3, right? So heap has two elements. Now we will pop the farther one. We will pop the farther one. Farther means here the large one, the large value. Further means here the large value. The large value we have is 10 here. So we will pop 1 comma 3. We'll pop 1 comma 3, right? So we'll pop 1 comma 3. So we will return the heap elements, this one as it is. So this one is smaller, this one is smaller, minus 2 comma 2. So this one, where is it? So this one, this is closer to the origin basically. So now we are left with minus 2 comma 2. So we will return this one as output. The answer that we got here is minus 2 comma 2, which is equivalent to the output that they have given for the example 1. So our approach works absolutely correct in this case, right? As our approach works absolutely correct in the case, we are done with the approach part. So let's move on with the complexities part. So what will be the time complexity and the space complexity here? The time complexity would be big of n log k. So the time complexity would be big of n log k. So why it is big of n log k here? So we are processing all the endpoints, and each heap insertion, we are going with a maximum priority queue, right? So, or the max heap. Here each heap insertion or removal takes log k, and we are going with the endpoint. So total overall time complexity would lead to big of n log k, big of n log k. So what will be the space complexity here? So overall space complexity would be big of k. Overall space complexity would be big of k, right? So we are maintaining a max heap of size k. We are maintaining a max heap of size k. So overall space complexity would lead to big of k. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n log k and big of k respectively, right? Big of n log k and big of k respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. We are good to write the code. Let's start writing the code. First, as I have said, we'll be making use of the priority queue with a custom comparator to simulate the max heap based on the distance, right? So I'll just go with a priority queue here. So this one within the int, this one within the int, this is fine. So let me make use of the variable pq. So this one will be new priority queue. So this one will be this is fine. Hmm. Yeah. This one will be a comma b, a comma b. So this has to be hyphen lambda expression, right? So this one will be integer. We are going with the comparator. So I'll just go with the compare, integer dot compare. So we have to go with the formula distance of b comma distance of a, right? So I'll just go with distance of b, distance of b comma distance of a. So why this one? Just give me a second here. This one is fine. Mm, this one is also fine. Yeah. This is fine. This is fine, man. So just give me a second here. This is fine. We went with the priority queue with a custom comparator just to simulate the max heap. right? Completely based on the distance. Next step, what we did in the approach, we have to iterate over each point, right? So we have to iterate over the each point. So I'll just go with a for loop here. So int p of points here. So within the for loop, we have to add the point to the heap. We have to add that particular point to the heap. So this one, let's make use of the let's make use of the offer that the priority queue provides, basically operation offer. So of p, right, individual points, we are adding point to the heap. So after this, if the size of the priority queue is greater than k, if the size of the priority queue is greater than k, then we have to remove the farthest point. Then we have to remove the farthest point if the heap exceeds size k, right? So in our case, we got 10 and 8. Farthest one was 10, so we removed 10. So we went with the solution minus 2 comma 2 for the first example, right? So same thing, the same thing we have to articulate in the form of code. So I'll just give here pq dot size if it is greater than k. If it is greater than k, then we have to remove the farthest point if heap exceeds size k. Nothing but pq dot poll, priority queue dot poll. So this is fine. Let me come out of this one entirely. So now we have to prepare the result array from heap contents. Now we have to prepare the result array from the heap content. So this one will be int, so int result equals, so new int of k along with 2 here. So let's go with a simple iteration here. This one int I equals 0, I less than k, I plus plus. So this is fine. Within the for loop, what we'll do, we'll extract the closest points. We have to extract the closest points. In our case, it was minus 2 comma 2 for the first example. We extracted the closest point, right? So I can just write it on this way in the form of code. Iterated value of the result equals. So for extracting the closest point, we'll be going with the poll operation that is provided by the priority queue, right? So I'll just go with pq dot poll, pq dot poll. This is fine. Hope this part is completely clear, man. So finally, let me go with, we have to return the result. Let me go with the return result. So one more thing here, I have given distance of b, distance of a. We have not written the helper method at all, man. We have not written the helper method at all. So I completely forgot. Somehow I have written this one directly, distance of b, distance of a, to calculate the distance. So we have to go with the this one, right, square distance from origin. So we are not going with a square root here. So we have to go with the Euclidean distance, basically. So let's go with the helper method to compute the square distance from the origin. So I'll just go with private and distance. So this is easy problem, I think, man. Oh, medium. So yeah, this is fine. Distance, so this one will be int p. This is fine. So all we need to do is return p of 0, p of 0 into p of 0 plus p of 1 into p of 1. So this is fine. So this is it for the code, right? So this is just the formula, man. We are not just going with the square root because it is not required, because basically we have to avoid the floating point here. That is the reason we are not going with the square root. Just remember this one, right? So we are done with the code. Let me hit the run button. I hope this works, man. Let's see. So yeah, you can clearly see here the sample test cases are getting passed. So let me hit the submit button quickly. Hope this works for all the test cases. Let's see. So you can clearly see here all the test cases are getting passed. Means the code works absolutely correct on this case, right? I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.